It is Fire Week here at Daily Planet. We've packed this week with, what else? Hot stories. Even we, though, will admit it's difficult to get hotter than this next one. You're about to meet a man, a physicist, who's not only going to walk on burning hot coals with bare feet, but at the same time, he's going to let us in on the physics of just how he manages to do that without hurting himself. On a cold winter's day in Pennsylvania, chopping firewood seems like a good idea. But David Willey isn't doing this to heat his home, and he's not about to have a cookout.
What I'm trying to do is get them about uniform size so they burn even.
In fact, the only things that might get cooked are the soles of his feet.
I'm going to walk across a bed of red-hot coals. It's going to be about 12, 15 foot long and at about 1,000 degrees Fahrenheit when I walk in bare feet.
David Willey is an amateur firewalker. Most days he teaches physics at the University of Pittsburgh, a job that requires a fair amount of sanity. So why is he doing this?
Well, there's several reasons. The first one is it's kind of fun, but the other one is that I'm a physics teacher and I got into firewalking by studying what the physics was behind it. And it's got some pretty interesting physics behind it.
He hopes to demonstrate the physics, something that's often misunderstood.
Yeah, it's people don't realize that there is a difference. It's temperature and heat can be explained, the difference between them, by thinking about a hose pipe. The pressure at which the water comes out is like the temperature of the wood. The amount of water that comes out of the hose pipe is like the amount of heat getting to my feet. Well, wood is the equivalent of an extremely skinny little hose pipe, and hence only tiny amount of water comes out, only tiny amount of heat comes out, even though it's at a high pressure, at a high temperature.
There's no magic involved in firewalking, it's pure science.
I'm ready now to light this, so I'm going to get a torch going so I can light it from a little distance away. There we go. And once we get this going, we should be in good shape.
The real reason a mere mortal can walk on hot coals is that wood and flesh are poor conductors of heat.
Get this going. Now, conduction is when two things are actually in contact with each other and the energetic, fast-moving molecules of the one thing knock into the slow-moving molecules of the other thing and speed them up, knock them into motion. Well, motion at the atomic level is heat. That's all it is. And that's how conduction occurs. But wood is particularly bad at doing this. And it's that poor conduction that I'm going to be relying on when my feet are on that wood, on that fire. And no, it doesn't really matter that this isn't on fire and that is on fire. It's still wood. It's still a lousy conductor.
The tiles on the bottom of the space shuttle are the same sort of thing. They're made of a material that's a very poor conductor and can withstand extreme heat.
This is a piece of the tile from the space shuttle, and that's a very poor conductor. You need the astronauts insulated from the re-entry temperatures as they come back in. And you can see from the bottom of it that this is orange hot. I'm going to pick up this piece of space tile while it's orange hot. And because it's such a poor conductor, it's not going to burn me. You watch. We pick it up, and even though it was in those flames just seconds ago, I can have it in my bare hands. Now, I'm not going to hold it for long, but neither am I going to stand still in that firewalk.
It's finally time for the firewalk. These embers are burning at about 1,200 degrees Fahrenheit. It's about 650 degrees Celsius.
Kids, don't try this at home. Let's go for it.
Let's see that again. The key to an injury-free firewalk is the minimal contact with the heat. His feet only touch the embers for a fraction of a second.
Oh, and if I could have a towel, I can show you, if I can balance, that my feet are fine. I don't think I even got a single blister there.
For David Willey, the worst part of walking on coals isn't the 1200-degree heat. It's the cold afterwards.
The only thing uncomfortable, to be honest, is the fact that once I get off the fire, they're pretty cold. Otherwise, my feet are fine. Whew. Another day at the office.
Fire, a source of mystery, terror, and primal fascination. The blue part of this flame can reach temperatures of almost 3,000 degrees Fahrenheit. What would happen to human flesh if it came in contact with a flame like this? An ancient ritual seems to challenge our expectations. A ritual known as firewalking. Practiced by Native American tribes and dating back to the Greeks and Romans, firewalking is a part of cultures and religions around the world. Perhaps the ritual reflects our ambivalence toward fire, which is a source of warmth and light, yet hot enough to sear human flesh and incinerate buildings. But how can human flesh be exposed to fire hot enough to melt aluminum and not be severely burned? Many firewalkers believe that it's a spiritual event, requiring intensive mental and spiritual preparation. Others point to the power of the human mind to protect the body.
Popular explanations seem to be that it's mind over matter in some way, that your body is putting out an energy that's counteracting the energy of the fire, none of which is true, of course.
For me, it's a belief in myself or my higher self, a higher power.
Higher power, some call it God.
Faith is the most important thing in walking the fire.
Your body will do whatever it takes to protect itself.
A scientific analysis suggests a combination of factors makes firewalking possible.
One of the main reasons that we can walk on fire is because wood is a poor thermal conductor. I have another example of a poor thermal conductor here. It's a piece of tile from the space shuttle. And even though now the temperature is up at about 1,000 degrees Fahrenheit, with it being a really poor conductor, I can pick it up and not enough heat energy gets to my hands, because it is a poor conductor, to burn me. This coal here is at about 1,200 degrees Fahrenheit. You can tell that because it's orange hot. And as long as I bounce it between my hands, I'm still okay. I'm not going to burn myself. I'm not going to hold on to it for any length of time, though.
Time is an important factor. Typically, a firewalker's foot is in contact with the coals for only 7/10 of a second. Not really enough time to cause a serious burn. Practicing mind over matter probably couldn't hurt, but I think a swift trip over the coals is the best ticket for a firewalker. For Skeptical Inquirer, I'm William B. Davis.
Of all the many things that feet can do, walking on water is only slightly more mysterious than walking on fire. Once the domain of Buddhist monks, today legions of people from around the world tread the fiery path of cinders. That's why Jay Cernitage has come to Johnson, Pennsylvania, to twist the fiery tail of the dragon. But his guru isn't a smiling little swami with a 10-syllable name. He's physics instructor David Willey from the University of Pittsburgh.
We actually are lighting the fire with paper shredded from old exams from my students, so they'd probably be happy about that.
David claims he can teach anyone to walk the walk. Today, he'll shepherd this small group of hopefuls over the coals to join the more than 2 million Americans who have walked the shining path of flames. How does he do it?
I think it's science. A magician could probably make it look more dramatic than I can make it look. I mean, science isn't what stops you from burning. Science is just an explanation of what's going on.
This is not just some idle musing. David Willey holds the world record for the longest firewalk in history. He and 17 followers traversed 165 feet, nearly 55 meters of 800-degree coals. Since then, he's had no trouble attracting disciples.
Well, I actually wanted to firewalk the first time that I saw David firewalk, which was the world's longest. And after watching everybody, you know, run back and forth and do their thing, it seemed interesting, and I wanted to do it the next time that he had one here.
This is no mystical journey, though. When David does his fiery road work, he takes as much 21st century technology with him as he can.
These are infrared images, so we can get an idea of the temperature from this color scale at the side.
Okay.
And what you can see is there's a vast difference between different parts of the fire, which explains why this foot's not going to burn because it's on a relatively cool bit, 600-700 degrees Fahrenheit. This is up more like in the thousands. I actually saw somebody walk on coals 1,813 degrees Fahrenheit. Now that's hotter than anything we're even seeing in these pictures, and the guy was okay.
What? You don't have to be a Buddhist monk? You don't have to invoke the protection of some omnipotent being? There's a scientific controversy at the glowing epicenter of firewalking. How can our feet handle the cauterizing coals and temperatures from 800 to 1,800 degrees? Is it mind over matter? Is it the nature of matter? Or is it simply the nature of our feet? Jay Cernatich is on the hot, high road to a new, mind-altering experience. By the end of today, he hopes to join an ever-increasing group of people bent on defying the odds and walking through fire. How can he accomplish this feat unscathed? Well, first of all, there is the Leidenfrost effect.
The Leidenfrost effect is when water comes in contact with a hot surface and a layer of steam is formed that insulates the rest of the water from that hot surface.
It wouldn't be as effective because if your foot is wet, it's going to vaporize whenever you take that first step, and after that, you will have no protection.
Well, that nixes that. But how about firewalker Tolly Birkin's theory?
Tolly Birkin has put forward the proposition that the blood flowing through your foot is picking up the heat and transporting it away from your foot, and that's what's keeping your foot cool.
Tolly proposes that our blood works like antifreeze, that it conducts the heat away from our feet to the rest of our body, thus keeping them cool. And although it's clear from these infrared images that the foot doesn't heat up very much over the course of a firewalk, David Willey doesn't believe in the radiator theory. He feels there's a simpler, more wooden explanation.
The fact that wood is a very poor conductor of heat. I mean, for years, people put wooden handles on soldering irons, saucepans to insulate them. The wood's a poor conductor. The dead skin on the bottom of your feet is a poor conductor. The ash that forms if you've got ash on top of the fire, that's a very poor conductor. And usually your feet aren't in contact with the coals for very long either.
As evening falls, Jay rakes the coals to rid the fire of hot spots. When the time comes, will he be able to face down his fear and walk the burning path? Will he brave the searing heat? Or will his resolve crumble and burn?
When you walk, don't run. Don't want to see anybody falling flat face into this. It's real bad news if you do. Okay? You want a nice brisk walk, maybe about that kind of a speed. Try and keep your feet fairly flat, almost consciously stretch your toes out.
Jay Cernatich has come to the firewalking workshop of Professor David Willey to temper his feet in a fiery baptism. He's set to challenge 15 feet of burning coals.
The idea is to walk on the fire, not in the fire. The tops of your feet are a lot more sensitive than the bottoms are, so really we want it to be just the bottoms of your feet that are in contact with the fire. We don't want anybody pushing their toes underneath the coals.
Skin between the toes and on the tops of the feet is particularly vulnerable to the searing heat. This top skin is thin and lacks the protective layer of callus found on the base of the foot. The fire is ready. It's a scorching 800 degrees Fahrenheit. Flesh blisters at temperatures as low as 120 degrees. It's time to separate the men from the boys.
Piece of cake? Yeah. Easiest thing you've ever done? I'll let you know in about a minute.
Jay is up next. Whether his feet are protected by flashes of steam, the low conductivity of ash, or cooling blood flowing through his feet doesn't really matter right now. Right now, all he needs is nerve. He's made it. And although he looks stoic, his walk was not without incident. Let's watch it again through our infrared camera. You can see just how hot it really is. Look right there. Jay's toes dig in, and the tops get blistered under the coals. But what's worse is the temperature differential between fire and ice.
Stepping into the snow was horrible, and I should have turned around and come back the same way.
Jay and his fabulous feet have conquered the flames, an extreme demonstration of our most extreme body part, the foot. So the next time you're walking over hot coals, or even just hot pavement, remember, your feet are a scientific marvel, the result of millions of years of evolutionary design. Need more proof? Just look down and place one foot in front of the other.